Okay, let's speak about the the self zone, which again, the self zone means that we're gonna build traffic, we're gonna build firewall policies with the self zone. It's gonna affect all traffic destined to the router or initiated by the router, which means we have two types of those: control plane traffic or management plane traffic. Now, as we saw before, because for example, we have configured no firewall policies, no policies on router 1 for the self zone, none of them. We have defined no firewall policies for the self zone. And control plane traffic worked because, for example, we have a VPN tunnel built between router 1 and router 2, which does a control plane traffic of IKE v1 in this case, which is UDP 500. Likewise, just to make sure, I can go to router 1 and I'm going to be able to telnet to router 3, and I'm going to be able to telnet to router 1 without any problems. Or I'm going to be able to ping router 1, ping and telnet. Let's confirm that. Let's go on 3 and try and ping and telnet to router 1. So ping 136.1.31.1, telnet 136.1.31.1. Okay, there's no password, but it works. Likewise from router 1, so traffic, this is traffic destined to router 1. Also from router 1, I can ping router 3, or I can telnet router 3. CISCO, and I let it to 3. That is because, as I stated, by default, all traffic initiated by the router is allowed. It's not inspected, it's allowed to work. It's not inspected, it's like a pass action. It's important to understand that it behaves like a pass action. You're going to see why. So traffic source from the self zone and destined to any zone, it is going to be like a pass action. It's allowed. So that's why, and also traffic destined to the router is allowed, but not inspected. It behaves again like a pass action. So traffic source from any zone and destined to the self zone is allowed like a pass action. So given our example in here, we have this to be the LAN zone. The tunnel is the WAN zone. Gig 01 is the internet zone. So as I pinged before from router 3 to router 1, ping or telnet. So ping or telnet. And it worked. That traffic was a traffic from internet. It was traffic from internet zone to the self zone. That was the direction of this traffic flow. Because the router 1 received that ping or telnet inbound on gig 01, which is a member of the internet zone. And because traffic was destined to router 1, it means it was destined to the self zone. So the traffic direction was from internet to self. Likewise, when from router 1, I pinged or telneted router 3, ping or telnet. Because that was router generated traffic, it means the direction of that traffic flow was from the self zone, from the router itself, and destined to the internet zone. That was the traffic direction. Initiated by the router from the self zone, and because it got routed out on an interface which is a member of the internet zone, it means that the firewall policy, the direction of that traffic flow was self zone to internet. And as we saw, both of those traffic types, they worked. Because as I stated, by default, traffic from any zone to the self zone, it's allowed like a pass action. Traffic from the self zone out to any zone, it's allowed like a pass action. And that's only control plane and management plane traffic, because only those two types of traffic have to do with the router itself. Now, why would I change these defaults? So why would I want to configure some policies which affect the self zone? In order to restrict or control traffic destined to the router, I gave one example in here, but it could be a lot of them. So one example could be in order to control or restrict traffic destined to the router from an untrusted zone, like from the WAN or the internet. Then you might ask, why can't I use control plane policing or control plane protection for that? Because as we saw in the first day of the class, control plane policing or control plane protection are applied globally at the router level. I cannot configure COPP or CPPR to control traffic per interface or per security zone. So as we saw on the first day with COPP or CPPR, I can restrict or police control plane traffic globally. How much of ARP traffic can the router receive or send? How much of ICMP traffic can the router receive or send? But it cannot configure inbound on which interface. Except of course for the management, for the MPP part, for the management plane protection, which allows you to restrict what management plane traffic the router allows and inbound on which interface. That's an exception, but for the control plane traffic like ARP, IGP, BGP, whatever, you cannot control that per interface. So what that means is that, for example, now the router is opened. So like if I run BGP on this router, for example, if I run BGP on this router, let's say that I run BGP for the adjacency over tunnel 12. So over tunnel 12, my protocol is BGP. I just chose up BGP. But also I can use the use case with OSPF, for example, or whatever. Somebody from the internet may try and kill the router, send traffic to the control plane, just like OSPF or BGP, to try and kill the router, or you're gonna try to get unauthorized management access via SSH to the router. For example, do you want simple test? Put a new router in the internet, like router 1. Put an inbound ACL and put the lines which says deny all traffic or permit, doesn't matter. It depends if you want to be able to manage also yourself the router remotely via SSH. Then in that inbound ACL, put a permit statement or allow the SSH traffic, but put the log keyword. And if you also manage it via telnet, which is not recommended, of course, put a permit action with telnet from the internet and with a log keyword. You're gonna see that you instantly get like tons of requests of, I'm gonna say who, from the internet tries to get unauthorized access to your router. And of course they're gonna be able to get in if you use a default username and password, which by default you have a default username and password on Cisco devices, or if you use a weak username and password. So I would want to make sure that, given that configuration of mine, which is, this is the LAN, and because I also forgot to state something. So what I want is, clearly I don't want to, let's say, limit the number of OSPF packets because I trust my network, but I gotta make sure that from the internet I don't receive any OSPF packets. I don't allow them. I cannot do that to control plane policing or control plane protection. So given this setup in here, with those three zones, LAN in here, LAN, WAN, and internet, if I don't manage the router remotely, I want to drop all traffic coming from the internet zone destined to the self zone. All traffic, all control plane traffic. Of course, zone-based policy firewall cannot match on non-IP traffic, which means you're still susceptible to an RPO attack from the internet, which you have to fix that up via control plane policing or protection. But for IP traffic we see from the internet, I want to drop all incoming IP traffic initiated by the internet and destined to the router, to the self zone. So I'm going to build a firewall policy, for example, which says traffic from the internet zone to the self zone, drop it all, for example. So to the self zone. I want to drop all the traffic from the internet zone, so from the internet to the router itself, which is to the self zone. All of this I want to drop it. Except, of course, I have to only allow the routing protocol which I speak with the provider. If that is BGP or some kind of IGP, I want to make sure that that protocol works, but only from the provider's IP address. Okay? If I use static routing, then I don't have to allow that. I'm just going to build a firewall policy which states traffic from the internet to the self zone, drop it all. Now, on the firewall policies which have to do with the self zone, inspect actions are supported, but are limited to TCP, UDP, ICMP, and HTTP/322 traffic. And this makes sense because traffic destined to the router or initiated by the router can only be TCP, UDP, ICMP, or if it's a voice gateway, HTTP/323. So for firewall policies which contain the self zone, inspect actions are limited to that, and it makes sense. And application level inspection and DPI is not supported. Like you cannot say match protocol, match telnet and inspect it, or to do some kind of application level inspection via layer 4, layer 7 class maps and policy maps of HTTP, telnet or FTP. You cannot do that. So the application level inspection and DPI is not supported for firewall policies which have to do with the self zone. So the only thing you got to make sure with the self zone is to make sure that with your configuration you do not drop important control plane traffic like IGP, BGP or IKE. If you configure firewall policies from the self zone or to the self zone and you don't allow traffic to work back and forward, it is going to be dropped by matching on the default class map, because what we're going to do is we're going to configure a regular firewall policy which matching traffic on a layer 4 class map, then setting the action in a layer 4 policy map, and then applying that policy map in a zone pair which is going to contain the self zone, so nothing special. So configuration verification is going to be as a regular zone-based policy firewall deployment, the same commands. So let's do the following. In our case, we are going to, let's say I'm going to configure a firewall policy, let's say from give me a couple of seconds to come up with a proper example, because I want to show also something which is important to know. Okay, so let's build a firewall policy from internet to self zone, which let's say I'm going to allow, let's use a pass action. I'm going to pass telnet traffic, or of course let's use SSH. So I want the router to be able to be managed from the internet and drop anything else. So I want all traffic going from the internet zone to the cell zone to be dropped unless it's SSH traffic. Let's build that firewall policy. So let's try and do it this way. Conft. So class map, type inspect, cmap SSH, match protocol SSH, exit. Policy map, let's name it pmap, from internet to self zone. And let's say class map cmap SSH. Class map, of course, let's remove the policy map and make it a type inspect. So policy map, type inspect, and then class map, my configure class map of type inspect for SSH, and then let's say pass. And everything is going to match on the class default, which is there. So do show run policy map. The class default is also by default under all policy maps. So this is what I have configured. Class map type inspect cmap SSH. And I'm going to have in here the default class map. Once I'm going to, of course, attach this policy map to a service policy. So let's put in notepad show run class map, my SSH class map, then my policy map, which is internet to self zone, and let's say zone pair security, and I'm gonna say ZP from the internet to self zone, and I'm going to say source internet, destination self, and I'm going to say service policy, type inspect, and this policy map. So show policy, show service, show policy firewall, type in show policy firewall config zone pair ZP internet to self. So there we go. This is what I've configured. Class map of SSH, match protocol SSH pass, and I also have the class default with a drop. As you can see instantly, the tunnel went down because the tunnel 12, it's sourced from this gig01. So because now inbound from the internet, I allow only SSH, IKE is going to match on the class default. Let's confirm that, and that's why the tunnel went down, the SVTI tunnel. So let's go under here, under this configuration, and to see all the logs, class default, which is again there by default, and let's say drop log. Let's keep the default drop, and also put a log in there. And let's say, let's shut down the tunnel, shut down the tunnel and unshut it. Shut down, no shut down. That's the SVTI tunnel. And as you can see, it stays down. It says dropping unknown, dropping UDP session from router 2 UDP 500 to router 1 UDP 500 because it matches on the class default. That is my IKE traffic. So that's why the SVTI tunnel doesn't come up, because negotiation happens over UDP 500. So there we go. We have to also make sure that I say in here, I build a new class map. class map of type inspect, let's say CMap for IKE, and mesh protocol, I'm not sure if it supports ISACamp. Here we go. Exit. So I match on the IKE protocol, which is UDP 500. And I have to allow UDP 500 traffic to the router, destined to the router from the internet zone. So I'm going to go under my configure policy map internet to self, and I'm going to say class type inspect CMap IKE and say pass. I want to allow inbound IKE traffic from the internet to the router so that that SVTI tunnel works. So now interface tunnel 12 shut down. Ergo it went up. Show IP interface brief. Tunnel 12 is up, which means show crypto ISACamp SA. Now my phase 1 is up. Show crypto IPsec SA. Phase 2 is likewise up. I have an inbound SA active and outbound SA active.